At the top of your paper it says, what is the linear parent function? What does linear mean? Line. Okay, so do we remember the parent function of a line? Ooh, good, I heard it. F of x equals x. Very nice. So way back in, I don't know what unit it was, last semester, we looked at f of x equals x, and then we put in this second equation so we could see how it changed. We are going to do that today. We're going to review here, and then today our goal is to be able to understand that for quadratics and parabolas. So this plus 3 made us move up 3 spaces, and this 1/2, right, because that was our slope, instead of 1/1 like the parent function, it was 1/2, so this was less steep. And again, that's what we're going to be looking at on the quadratics today. So we've graphed in Desmos our f of x equals x, and then we're seeing how it changed. So the second equation was the one they gave us. G of x equals 1/2 f of x plus 3. So we need to decide, how did this change? And when we did this the first go around, we said you could like take off the plus 3 and see what the 0.5 did, and then take off the 0.5 and put the plus 3. We could do that as well, or we can just look at this. I want you to notice on this part. How did the green line change compared to the red line? It is less steep. Okay. What number do you think did that? The 1/2 or the plus 3? The 1/2. Okay. And then what did this plus 3 do? What do you see happened here? Yeah, it went up 3. So we're going to write that on our... When we talk about quadratic parent functions, that is a little bit different than the linear parent function, but not much. We know a quadratic has to have a squared. So our quadratic parent function is f of x equals x squared. And we actually talked about that way back on day 1. What we're going to do today is we're going to look at what that looks like in a graph. So on a graph that goes through 0, 0, and then it's going to go up 1, right 1, up 1, left 1. This is always the pattern for the parent function, and it's going to go up 4, right 2, up 4, left 2, so that you can see those buddy points happening. And our goal today is to find out how the quadratic changes compared to this one. When we're looking at how things change, I want you to be aware we're going to be looking at some different letters. Okay, and our goal today is to figure out what most of these letters are. We'll do one of them tomorrow. So A times F parentheses X plus or minus, I'm sorry, not plus or minus, B X. I always forget the B. We're going to do B tomorrow. B X plus or minus C, close parentheses, plus or minus D. Okay, we're going to figure out what all of these letters mean by the end of class tomorrow. In order for us to do this, we're going to kind of do a little bit of discovery. So we'll come back to those boxes, and we're going to be graphing all of this in Desmos so we can see what is happening. So let's make a couple of notes about what happened. I'm going to come back to the 2 in just a minute because that one is a little trickier. So we said this 3 was up 3. Okay, we actually call that a vertical shift because up, down is vertical. Right here, this minus 5 is not left. This is a right 5. Again, insiders lie. The 2, we said it got narrower. Now, when we talk about that, we're actually going to put here, we're going to talk about vertical stretch. Okay. And a vertical stretch is what makes it more narrow. So I want you to think about if you are in the weight room and you are doing a bench press, okay? So when you do a bench press, you are, holding the bar, you're laying down, you're holding the bar, and your arms are kind of, I don't know if they're supposed to be 90 degrees or curved, but they kind of look like the parent function, like a parabola, right? So when you vertically go up, your arms are stretching up, Does that make sense? Okay, so when you get narrower, your arms get narrow, it's because you're doing a vertical stretch. What happens when I come back down? My arms get wider, and this is going to be what we call a vertical compression because we're squishing what we have, we're making it wider. Okay? Let's look at this one. We're going to change that second one to 1/2 and a -2. So here, this is a vertical compression, which means it got wider as opposed to the one before, which was a vertical stretch and it got narrower. And then this -2 just made us go down 2 spaces. So this negative made us flip over the x-axis. The x-axis is that one that's horizontal. When you were in 8th grade, you called that a reflection, right? FL in reflection for flip. And then this is still going to make you go up 1, right? So if we're adding or subtracting on the end, that's just an up and down. But that negative caused our whole parabola to flip. We're going to do one more. We're going to see what happens. Does anyone have an idea of maybe, you got a prediction? Okay, I heard down 3. I like that. Anything else we can predict about? Ooh, yes, you're right. It is going to flip because it has that negative. Flip over the x-axis, or you could just write reflection, same thing. We think it's going to be a vertical stretch or compression. I might have to look at that one. A compression. Okay, so we think it's going to get wider. We'll double check it. Anyone think they know what this +7 is going to do? Insiders lie. Ooh, I heard a left 7. Okay, let's check our predictions and see how we did. So to summarize, the A, that is that number in front of your f of x or your x squared, whichever they happen to give us. And that is going to be our vertical stretch or our vertical compression. So if A is bigger than 1, okay, I'm not going to say if A is like 2 or 3 because it could also be a fraction that's bigger than 1. It could be, 5/4 or something like that. If A is bigger than 1, this is going to be a vertical up and down stretch, meaning that our graph is going to be narrower or skinnier. Okay, so like we did on example 1. But if A is between 0 and 1, again, I'm not going to say a fraction here because fractions can be more than 1. But if it's like the 1/2 or the 1/3, or if it's a decimal, 0.75, this is going to be a vertical compression. Okay, so again, think about the bench press. You're going up or you're going down. And if it's a vertical compression, it's going to get wider. The only other thing we need to add to this is if A is in fact a negative. What happened when it was negative? It was a flip. Good. It was a flip over the x-axis, which we also call a reflection. So those are the 3 things. So if you have a number in front of your f of x or your x squared, that's what it's going to do. We're going to worry about B tomorrow, but I do between B and C. I want you to notice that B and C are both in parentheses. So I'm just going to draw a little arrow between the 2 of these, and I want you to remember they are inside, and insiders, they lie. So when we talk about B and C, they're going to be lying to us. So we're going to have to keep that in mind. So C is going to be, when we're going across, this is going to be a horizontal shift. Now, how it shifts depends on the sign. So if we have a positive C, positive usually goes to the right, but again, insiders lie, so we're going to shift left. If we have a negative C, again, negative is usually left, but insiders lie. This is going to be a right shift. So just to kind of recap that, if we had F parentheses X plus 2 and F parentheses X plus 5, what would or not plus 5, minus 5. Do one of each sign. What is a plus 2 going to do? Normally plus 2 is to the right, but because it's inside, it's lying, so this is really left 2. And a plus 5 is going to go, a minus 5 is going to go to the right. Because again, they're lying. It's the opposite. All right, so this one is not in parentheses, so this one is just going to be what it is. But again, it's not in the parentheses, so it's not going to be horizontal shift. It's going to be a vertical shift. So if it's not in parentheses, it's going to be up and down, just like the bench press. Your arms go up and down. So vertical shift. So if our D is a positive, it's going to do exactly what we think it's going to do. What is it going to do? It's going to go up. This is going to shift up. And if it's a negative D, what is it going to do? It's going to shift down. So that would be written differently than the one we just looked at. We would have f of x, and then outside the parentheses, we could put plus 2. F of x outside the parentheses, we could put the minus 5. So what does a plus 2 outside the parentheses do? Up 2. And the minus 5 is going to be down 5. So now that we've put this into Desmos, right, the red one is my original and the green one is my new one. I do love using Desmos because you can tap and you can see the different coordinates. What do you just notice in general before we do talk about anything specific? What did it do?
It's thinner.
All right, it is thinner. Okay, if I was to take off my 5 and my 3, then you would see, in fact, actually let me use green so it matches. It would go here and here. So remember, you can take away pieces so you can see it. So it is, in fact, thinner, and the reason it is thinner is because of the 2. What else did it do? It moved up 3. Very nice. Okay, so we went up 3. What else did it do? And it went across 5 to the right. Okay, so we're going to talk about those things. The up 3, that's very easy to see right here. The right 5, let me ask you about this. This says minus 5. Is minus 5 usually a right? No. Okay, so when we did this before, we talked about insiders. Insiders lie. So because the 5 is inside the parentheses, right? Minus is usually left, but it's lying, so we're going to go right. So think about a spy inside of an organization. They're lying about who they are. So on this one, you can see very easily that it moved where? Where did the graph move?
Under.
It went under. It went down 2. Okay? So that's going to be here. Now, this number in front of the x squared is different. And you can see, in fact, that my green is wider than my red. So unlike the one before, this is going to be what we call a vertical compression. We're taking that parent function and we're squishing it so it gets wider. So just like we were just talking with the bench press, right? If you're bringing your arms down, your arms are getting wider. So this is going to be a vertical compression. This one looks a little bit different. Okay. It did go up, which... Someone said a minute ago. It went up 1 because we were at 0, 0, and now we're at 0, 1. So that didn't change. But what did this negative do?
Made it under. What?
Yeah, it made it flip, right? So we went from opening up and having a min value to now it's opening down and we have a max. Okay, so let's look at what that did. So it looks like you guys were pretty spot on. So it did go down. It went down 3. It went left 7. It is, in fact, wider. And it flipped. So great job, great job. So let's look at what all of this is together on our boxes.